Welcome to this edition of At Home with APS. Hi, my name is Mrs. Gaudette, and I'll be working today with you with math for 3rd, 4th, and 5th grade. So we're going to start with routines, moving into a task, do a read aloud with a book, and then play a game. So we have much fun activities planned for you today. So let's go ahead and get started with the routines. Today we're going to start with a number of the day. So I have the number 3,789. If you were here last week with us, one thing that Mrs. Sears and I keep working on is not saying that and when we're saying the number. We want to say 3,789. There is no and. Do you guys remember why there's no and? Some of you remember that and means a decimal point, meaning there's something coming on further on from that number. Every time you say an and, you're saying, if I say 3,700 and, that means I have a decimal point here, and I'm moving on to decimals. So we just want to make sure of that. So the first part of what we're going to be doing is we're going to be placing them in the place value chart, really talking about the different places for place value. So we have 3,789. I'm going to go ahead and start with our ones. How many ones do we have? 9, right? So we have that one spot right there. So we know we have 9 ones. Then let's look at how many 10s do I have? How many 10s do I have? So you guys are calling out, just like last week. Call out those answers to me. Talk to the TV. Talk to an adult or someone at your house. We have 8 10s, but how would we say that? 80. We have 80. All right. How many hundreds do I have? We have 7 hundredths. And how would I say that? How much is 7 hundredths? It's 700. Good. And the last one is thousands. How many thousands do I have? We have right there, we have 3,000. 3,000s. And how would we say that? 3,000. Thank you. So let's move on to the next one. So here we're asking you to do a base 10 blocks. So I just wanted to review the base 10 blocks with you. So since we're working with thousands, we have that big old cube. And we call it a cube. And we always ask how many pieces are in there. We have to know that that cube always equals 1,000. Our hundredths, which is our flat, is worth 100. And you can, if you were sitting here counting, I didn't do it with this one because it's really hard, but you can see I have 10 in each row, and I have 10 rows. So that makes a 100. Then I have a rod. Some people call it a strip. We have a rod, and that's worth 10. And then I have 1 unit, 1 individual square. Now, for our work today, we need to know how would we write that down when we get there. So for a cube, here's a quick little lesson I did in 5th grade that I loved. One of my teachers came in and helped us out with our drawing. When you write a cube, when we write a cube, or draw a cube, I apologize. When we draw a cube, we have to have that square, but then we have to make it look 3-dimensional. By doing that, we draw another square that's offset from the original. And then what we do is we just connect all the vertices, which are the corners. So we connect those corners, and then I draw a dotted line here. So you can see that technically you wouldn't see that edge, like we don't see that edge right here. So that's how we would draw our cube. For our flat, we just do a square. For our 10s, the rod, we would just draw what a lot of us would say that just looks like a 1. But we're going to say that is a rod worth 10. And then our last one, the easiest thing to do is just do a little point, or what I would consider like almost like a period. When you're writing, you just do that little period at the end of a sentence. That will be our unit. So when we're working today, we'll have you draw it like this: a cube, a flat, a rod, and a unit. All right, so let's go ahead and let's move on to our next page. So draw the base 10 model of this number, 3,789. Practice it with me, 3,789. So we're going to go ahead and get that going. So I'm going to start from this way, from the left going right, since that's the way we say it. How many thousands do I have? Remember what we did earlier? We said there was 3 in there. So I have to draw how many cubes? Yep, draw 3 cubes with me. So again, we draw that square. We draw an offset square. And then we connect the vertices, which are the corners of that square. And then I do a dash just so you guys can see that that would be there. That's 1,000. 1,000 cubes. 1,000 units. Let me use the correct terminology. So let's do it again. And are you guys doing this in your notebook that Ms. Sears asked you guys to have? Did some of you remember that? Some of you not so much. Make sure to have paper or a notebook that you'll be doing all your work with us in. And then I have now my 3 cubes. So next, I need to go into my hundreds. I have 3,789. How many hundreds did we have? 7, thank you. So we just go ahead and do that flat, which was a square for us. So we have to do 7 of these. So I have 3, 4, 5, 6, and 1 more. Thank you for reminding me about that last one. All right, I have 3,789. How many 10s did I have? 8. So I have to do that rod. 1, 2, 3, 4, 5, 6, 7, 8. And how many 1s? 3,789. Good, thank you. We have that 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I really like the base 10 blocks because it really breaks it up for us and really think about that number versus just looking at some random thing and not knowing really what it means. This helps us to figure out what is really in that. Don't you wish you had $3,789? I sure do. All right. Now let's go ahead and go with place value. What is the value? So we had started talking about that. So 3,789. What is the value of the ones place? Just 9, right? We just had that 9. Did you guys catch me that I forgot to get my pen? All right, so we had that 9. Value of the tens place. We have 8. So the value is 8. Did you catch me? Look at those people. It's not 8. The value is not 8. We have the 8 is sitting in the tens place. So the value is 80. Thank you. So we have 80. What is the value of the hundredths place? Thank you. 7. I already know it. Yep, 700, because it is sitting in the hundreds place, so you have to make it 100. Think about it like that, and that might help. Value of the thousands place. So we had that 3,000, or those 3 cubes, remember? And we said how many was in each cube? 1,000. So we would move that on, and we have 3,000. All right. So, the number of the day, write our number of the day in the different number formats. So standard form, how would you rewrite it in standard form? You would just write 3,000, comma. We can't forget the comma because what does the comma tell us? It separates everything, so we know it's thousands. 3,789. Expanded form. Oh, now those place values will help you. So we had 3,000. Yes, thank you. So we have 3,000 plus 700. So we bring in the 700 plus 80 and then plus 9. And we have our word form. How do we read it is how we will write it. So we have to write those numbers out. So we have 3,000, and we have to spell it out. 3,000, comma, 700, comma, because we're still saying it, and then 89. So with this one, this is a little different. We just say 80, and then we write our dash for 9. 3,789. So those are our formats. So thank you for joining me on the routine. We're now going to do a task, a couple different tasks together. Thank you. So with this, you are going to need a sheet of paper. And with that paper, what you're going to need to do is you can have either 4 sheets of paper, you could have one sheet that you make sure you get a square and then cut it the square in 4ths. So we're going to have here, I have 1. And what I'm going to ask you is, for each of those squares, so I have 1, 2, 3, 4, each of those squares, think of the different ways that you can make 1/4. All right, so I have the first one. How could I make that into a 4th? Have you guys thought about this? So the easiest way I always think of is I fold it in half. Sorry, this is nice, very nice cardstock, so it's going to be a little harder to fold than yours. So you can see I have half and I have 2 identical halves. When I take those 2 identical halves and split them in half again, you will get, and I'll bring out my beautiful, oh, that's going to make it an awful looking color. So I have here, so this is what I would like you to do. Make your halves, and then make it into a 4th, and then color in 1/4 of it. While I sit up here and do on my example, but what I'd like you to think of, what other ways could you and I make 4ths? So I said we cut it in half, and then we cut it in half again. That will give us a 4th right here, right? 1/4, there's 1 piece. Remember, we've talked about this, 1 piece out of 4 pieces. Probably should do it a little darker, huh, so you can see that. Okay, did you guys think about another way to do it? I know. What if I folded it in half a different way? Do you have an idea where I can get my 4ths now? So we can get it that way. All right, so now, just like we did last time, we color in one of them, and we have a 4th. So I'm going to color in this one, but I am not going to do the other 2 right now. I'm going to leave the other 2 with you so that you can think about how the other two, and then tomorrow I can really quickly just show you the other two. All right, at least the other two that I can think of. Maybe you came up with a different one. But remember, with these, we have to have equal pieces. They cannot be like a piece like this. Because does this piece fit that piece where I could overlay it and it'd be exactly the same? No. So that won't work. All right, so let's go ahead and let's get into our work today. So we're working with understanding fractions all week. You guys are lucky and get to do fractions with me. Mrs. Brown cut a 6-meter rope into 3 equal-sized pieces to make jump ropes. Mr. Ware cut a 5-meter rope into 3 equal-sized pieces to make jump ropes. Which class has longer jump ropes? So if you were with me in the spring, I always do what I called a modified marking up the text to help me understand what I need to be looking at. So the first thing I do is I always circle the information, that number information or the quantity that I have. So I know that I have 6 meters here, and then I have 3 equal-sized pieces. So I know for Ms. Brown, we have that. For Mr. Ware, we have the 5 meters and then the 3 equal pieces. What are we being asked to do? Who has a longer jump ropes? So let's go ahead and let's do some math. All right, again, I'm thinking I have a 6-meter rope and 3 equal pieces. So let me do that one. We have I'm gonna make it into a rectangle because it just makes it better for me to understand my fractions. If you did it like this and just took the rope, that's fine also. It's just what works best for you when you're doing it. So remember that. And people do things differently, and that's okay. So I'm going to do 3 equal pieces. And I know this whole thing is 6 meters. Don't forget your unit. I know Ms. Sears talked to you last week about that. And that was Ms. Brown. Or Brownie. I don't know which one. What do you guys think? Mr. Ware had, I messed up there, didn't I? He had only 5 meters, so it can't be the same size, can it? Right? Did you guys catch that? So this is 5 meters. And again, it's 3 equal pieces. So my question to you is, who had the longer jump rope? Well, you guys are looking at my picture, right? And you notice here, this piece looks bigger than this piece. Why do you think that's the case? I didn't draw very good equal sizes, did I? Did you draw better equal sizes? This probably should have been more over here. So who had a longer jump rope? Yeah, so let's go ahead and write that out. Ms. Brown, I actually like Brownie better. Why do you guys think I like Brownie better? Oh, brownies, I love brownies. Ms. Brown has a longer jump rope because she started with a longer rope. Okay. Oop, I need a period on my sentence. There we go. So we have that. Now you notice there is another question there for us. Is how long are the jump ropes in Miss Brown's class? Do you think we could solve that? Thank you for joining me to solve that. Again, remember, There is all of what I'm working on is online, and you can download and work through those prior to getting my answer. So remember, I'm just giving you one way that I approached it and how I thought it through. But remember, you could have approached it completely different, and you could just check your work against my work and see how our different thinking is. And then if you're one of those things like, I might need to revise, do it again, because remember, the more times we do things, the more likely we're to remember things. If we just do it one time and go, I got it wrong, well, you're not going to remember anything. You got to do it with me. All right, so how long are the jump ropes in Miss Brown's class? What are we being asked to do? Right? Find out how long. So how long we are. So I know that she had 3 equal sizes, and they were 6 meters long. She had 3 equal sizes, 6 meters. So what equal sizes could I do to get to 6? Those equal groupings. So what could I multiply by 3 to get 6? Or repeated addition. 1 times 3 equals 6. 1 plus 1 plus 1. No, that doesn't work. That equals 3. Ding, 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 ding. Thank you. So we know, right, that 3 times something equals 6. And several of you said, it's 2, Mrs. Goddard, it's 2. 2, 4, 6. Yep, that does work. So let's write it out. How long are the jump ropes in Miss Brown's class? The jump ropes are 2 meters long. All right, did you guys get that? Make sure to write it down. All right, so let's go ahead and let's move on to the next understanding fractions. Now we're with Andre. Andre's mom baked 2 of his favorite cakes. What a great mom, right? My mom sure didn't do that. For his birthday party. The cakes were the exact same size. Andre cut his first cake into 8 pieces for him and his 7 friends. The picture below shows how he cut it. Did Andre cut the cake into 8ths? Explain your answer. So first off, let's circle what information we have to help us solve this. Well, he cut the cake, right? So I'm going to go ahead and circle that. Because even though it is not a number, it is very important to the information we need. He cut that cake into 8 pieces for him and his 7 friends. He's only needing 7 of those pieces? Why would he do 8? Did you catch that? Him and his 7 friends. So how many people are going to get a piece? 8. So this right here equals 8. Him and his friends. Now let's go ahead and underline what we need to answer. The picture below shows how we cut it. Do we need that to answer? Nah, that's just information, good information, but not information we need to answer right now. Did Andre cut the cake into 8ths? Is that what we need to answer? Yeah. So is the cake cut into 8ths? So let's look at the good piece of information, but we didn't need it to right away. Are these 8ths? Well, if I sit here, I have 1 piece, 2 pieces, 3 pieces, 4 pieces, 5 pieces, 6, 7, 8. Yes, he did. Do you agree with me? We got 8ths there. No. We don't have 8ths, do we? Why don't we have 8ths? Do you guys remember? Some of you remember from my boo-boo earlier. Did you remember that? How I didn't make equal size pieces, right? Did you guys see that? These aren't equal size pieces. This piece right here, the one on the far left, is probably about the length of my finger. But at this next piece right next to it, probably, gosh, almost like 2 of my fingers. Whoa, that sure is not equal pieces. So my question is did Andre cut the cake into eighths? What was our answer? No. Andre did not cut the cake into eighths. Why? What is our reasoning? Oops, eighths, sorry. Because now, see, just saying no does not answer the question, right? Remember, we're working on how you would solve that. No, Andre did not cut the cake into the eighths because, what did we just discuss? They're not equal pieces. Are not equal pieces. And remember, to be eighths, what we had just discussed, to be eighths is they had to be equal sized pieces. They can't be random, like big size, little size, cut with the diagonal. They have to be the same size, same shape. We can't have all these different random sizes. All right, so we're gonna move now into our next activity, which is an awesome book, which really goes very well with what we were just talking about with Andre. All right, Mrs. Sears.
Okay. Got a few things I've just got to put up here to the side so we have that when we're ready to go. And we want to get onto our document cam, which hopefully we can see our story today. All right, so our story today, let me just make sure you guys can see that really, really good. Our story today is, hi, I'm Mrs. Sears, and hello, mathematicians. Our story today is called The Lion's Share. And it's about a bunch of animals in the jungle. So I kind of wore my cool little print with you today. And we're going to read a story. It's similar to Miss Gaudette's problem in that they are having a party and they're going to be splitting up some cake for that party. So let's read this story. So it's The Lion's Share, a tale of halving cake and eating it too. Did you catch that? Halving? Not having, halving cake and eating it too. It is by Matthew McElliott, and our publisher, let me go ahead and get to that, is the Walker Company, and Walker and Company from New York. All right, you guys ready to begin? Cool. Now let me see if we can get that. Can you guys see that pretty well? Perfect. All right, every year at the start of spring, the lion invited a small group of animals to join him for a special dinner. A little bit further over, kind of playing with our document camera today. The ant had never dined with the king before. She was very nervous and wanted to make a good impression. When the day came, she arrived exactly on time, not a minute too soon or too late. I always like to be on time too to my parties. Sometime later, the beetle arrived, then the frog, the macaw, the warthog, the tortoise, the gorilla, push it up, the hippo, and the elephant. They were all late. So that ant was on time. She really must have really wanted to be at that party, right? Okay, let's see if we can see that. When dinner was served, the ant was shocked at how the others behaved. The elephant talked about himself constantly. The hippo never wiped her mouth. The gorilla threw his food, and the warthog tried to eat the flowers. Look at this crazy scene. Does that look like dinner at your house sometimes? Yeah, sometimes at my house too. What strange manners, thought the ant. She looked to the lion, who said nothing. Wonder what the lion was thinking about all those different people at dinner. All right. After dinner, the table was cleared and a large cake was brought out for dessert. Love cake. The lion passed it to the elephant. Please help yourself, he said. What do you think the elephant did? The elephant's pretty big, so. The elephant looked at the cake. I could eat this in one bite, he thought, but that might seem greedy. With a grand gesture, he cut the cake in half and passed the rest to the hippo. So look at that cake. It was a big cake, and he cut it in half. Took a half of that cake. All right, what a pig, thought the hippo. But if he's taking half, I'm going to take half of what's left. So she made a slice. What do you think she did? She cut it in half too, right down that middle, and handed the remaining 1/4 of the cake to the gorilla. So now first we had that whole cake, now we have a half of a cake, they cut that half in half, and now we have 1/4 of the cake. What do you think the gorilla is going to do? Then this continued around the table. Look at that gorilla. What do you think he's doing? I can see it now. He's cutting half of that 1/4 as each animal, they cut half that 1/4, that we have an 1/8. Now the 1/8 is being passed to the turtle, and the turtle's gonna get 1/16, and then took half of the remaining cake. Half, 1/16 is 1/32, 1/32. I can't even say that, 32ths. And passed the rest on and on until, what do you think? What happened? It finally reached the ant as she struggled to cut the tiny slice into 2. It crumbled to pieces on her plate. All the animals turned to her. What do you think they're going to say about the ant? Typical ant, said the elephant. She thinks only of herself. When the cake came to her, I shared it. I know, said the hippo. We all did. Look at them. They're still eating their cake. Doesn't she know the king hasn't eaten yet? Scoffed the tortoise. The warthog, who was sitting in her cake, she's sitting in the cake, shook her head in disgust. I don't think that was very fair of them to say that. What do you think the lion's going to say? The ant was mortified. Surely she would never be invited back. My king, said the ant, please forgive me. I'm ashamed to say that there is nothing left to share. But if you will allow me the honor, it would be my honor to bake a special strawberry sponge cake for you tomorrow. It is my grandmother's recipe, and I think you will enjoy it. The king smiled. Thank you, he said. You are very generous. She's going to bake him a whole new cake. Strawberry shortcake, too. Sounds pretty good. We can get that over there. Who does she think she is, thought the beetle. He scampered over to the lion's plate. My king, to show you my thanks, I would like to bake you 2 cakes tomorrow. A double chocolate fudge. Boy, the king's gonna really have a lot of cake now. 2 double chocolate fudge, and 1 of that strawberry. Let's see. I think there's a pattern going on here. Hey, king, said the frog. I'm going to bake you 4 raspberry layer cakes tomorrow. That's twice as many. Well, I can top that, announced the macaw. I shall bake the king twice as many carrot cakes. What's twice as many as 4? 8. And he shall have them tomorrow. Then I'll bake twice as many mud cakes, snorted the warthog. How many is that? Exactly 16, said the tortoise. Really, said the warthog? That sounds like a lot. I think so too. Maybe for you, said the tortoise, but I will happily bake twice that. Twice as 16? 32. Apple walnut cakes will be ready by tomorrow afternoon. Boy, they're really going to have a party with all of these cakes. The gorilla looked at the tortoise. He didn't like the tortoise, and although the gorilla had never baked anything ever before, somehow he found himself offering twice as many as banana crumb cakes. How many? 64. Yeah, 32 times 2 is 64. Double it. 64, asked the king. Are you sure? The gorilla nodded. But the gorilla didn't look too sure. I'd probably take me a while to figure out how to bake all of those too. Let's see. Can we get that in there? All eyes turned to the hippo. Naturally, she stammered, it will be my honor to bake twice as many spice cakes. Let me see. She took out a piece of paper and began to scribble some numbers. Her hoof was shaking as she put down the pencil. Oh my gosh, this can't be right, she finally thought. How many do you think she had to make? She had to make double of that 64, right? Oh, think you can see the answer there on the other page. The gorilla grabbed a piece of paper, 128. Now they have an and in there. I would have said 128. He announced with a grin. The elephant was crestfallen, but he had to top the hippo. Elephants were twice as good as hippos. With a deep breath, he announced, and I, the great elephant, shall bake twice as many as the hippo. 246 peanut butter pound cakes. 56. Oh no, he said 46 first. Let's see. 256. That's what I thought it was going to be, double of that. Corrected the tortoise. Oh, for goodness sake, cursed the elephant. See, they're checking their math too. I like these animals that are thinking about this. That night, the ant baked her cake for the king. She took her time and measured everything carefully. She spread the frosting as smoothly as she could, then decorated the top with sprinkles. It was a very, very fine cake. Wow, that looks delicious. Looks like it's going to be delicious. Wonder what all these other animals are having to do. Look at them scurrying around, trying to figure out all the different measurements in the baking. The next morning, she delivered it to the king. Such a fine cake, said the lion. Won't you share it with me? Won't you share it with me? Now, do you think she got her fair share? Yeah, she probably did get a pretty good fair share after that. What do you think about that story as far as the animals? Did all the animals get a fair share? No, they didn't. They started off just having one big cake, and instead of kind of thinking about it in terms of those equal pieces, they started halving that cake, right? So I thought that you guys might want to try and play with that a little bit, okay? So what we did is we've got some pretend cake here. And what I thought we could do is we could kind of talk about, like, see if I can get that up there where you can see that. How did the animals split the different cake as they were going? Okay, so let's picture this. This is our cake that we had. The lion that had the cake at the party, brought the cake out there for the party. What did the elephant do? He cut it in half. How could we represent that? Let's see, what could you do that? You could probably take your paper and fold it in half, right? And then use some scissors, if you can get a grown-up at home. If you don't have scissors handy, have a grown-up go get those scissors for you. You could cut that cake up and you could divide it in half. I've already got a piece here that we can work with, that we can show you that we divided in half. And that half would be for our elephant, right? Go ahead and put that over there. Then what did they do with that half? Oh, they cut it again, right? So if we had this half that we started with, and we were to cut that again, how much did we have then? Oh, it was a quarter. What's different from this fraction that we notice? The denominator's different, right? Yeah, what happened to that denominator? Oh, when we cut it in half, it got like more pieces. It got bigger, right? And from what we know, when we cut something up and we get smaller pieces, we have more in that denominator than we do in that numerator. One thing you should notice about our numerators is that they're all unit fractions. They're all one piece out of the big puzzle. Okay, what happened as they continued to go? Oh, they took that quarter, right? And they cut that piece in half, right? So if we did that, what do you think that next fraction's gonna be? 1/8, right? And I was trying to remember, who was the third one in the story? The second one was our hippo. The third one in the story, wasn't that the warthog? Or was it the gorilla? I can't remember on there, but that happened to an 8. And you can continue to do this as you go, making each of the different fractions as you get closer and closer to predicting that. What you're gonna notice that's gonna happen is as you get down really, really close into those fractions, you're gonna start to realize, yeah, okay. You're gonna start to realize the pieces get smaller and even smaller and smaller to where we almost don't have any pieces at all. And that was where the poor ant kind of didn't have anything left that you realize that they can do. Let's get that on top of there. And you can see. So when we got down to it, the ant had almost nothing. All right, so I'm gonna just show you a quick little visual on how that would work. I'm gonna go back to our PowerPoint. You kind of have an idea and you can be working on that. And there are some ideas that you can also do on our lesson resources. There's a game that you can play, and there's also a activity that if you wanted to do this with like a Pop-Tart at home, kind of shows you and walks you through how to do that as well. And let's see if this will work. It's not hooked up. It's not hooked up, is it? Okay. Perfect, thank you. And we're gonna get ready to go to our visual. Okay, so if you remembered what happened, we had our elephant that took half. We had then our hippo. And as we get bigger, what happens to the pieces? They get smaller and smaller and smaller to where there's nothing left for that poor ant, right? Yeah. It's almost kind of sad. I wish I would have been able to have that cake. All right, I'm going to invite Miss Gaudette up here with us, and we're going to play a game, okay? And our game that we're actually going to be playing is called the product game. Don't we have to have our little scribble up here? Okay, so let's explain how this product game works. What do you notice up there? Well, I see an array. I see a lot of different numbers that are up there, and I see something that says factors down here. I wonder if we got to use those factors to multiply together to get a product and do something with that in order to win the game. Yeah, that's exactly what we have to do. So all of these are products, different products that these factors are going to make. Okay, Miss Gaudette and I can each choose 2 different factors, and let me say you can use, I shouldn't say different, because you can use the same factor if you have to. If we know something about our square numbers, when we're going to multiply a number by itself, we are going to have to use the same factor that goes in there.
Let me clarify. You said we're going to do it on here because we don't want to put the sticky notes down here. But down here, you could use like paper clips or something just to cover it. But the way she described it is we're each going to choose different factors.
No, we're going to somehow repeat some of the factors that we're going to use. So keep going. You're doing fine.
All right. So with that, like, we're going to pick a factor. The first person picks 2. But from then on, you're only allowed to move 1 paperclip or Post-it note at a time.
At a time.
I can't choose like her pick 2 and then I just move 2 randomly. Then it would be so easy to win.
Yes, because we could probably get this. The object of the game is that we've got to make 4 in a row, and we have to make 4 in a row horizontally, vertically, or diagonally.
I think it's like Connect 4. That's kind of the rules of like Connect 4.
And it's a lot of strategy involved. So you really got to be thinking ahead kind of a few steps. I know Ms. Gaudette and I get kind of competitive here, but you got to kind of be thinking about a few steps ahead and which factors you're going to want to choose so that you can kind of get those 4 in a row. Okay? All right, so because I'm the first player, I get to start with, I guess I'm the first player, I just chose. I get to choose 2 factors that I'm gonna multiply together to get my product, and then I'm gonna mark that product on the board. Then when Ms. Gaudette goes, she's gonna try and use one of my factors, okay? And she has to put it on another factor in order to get the next piece that's going to be put on the board. And we're going to be doing different colors. So if you have something at home, you know, for a marker or a counter, something that you can put on that would distinguish who's who when playing the game. Because remember, the first one that gets the 4 in a row, that's the winner.
All right, so I have a question for you. What happens if I come up with a product that's already covered? What happens?
Then you lose your turn.
Oh.
Yes. Okay. Because there is nothing else where to put that on the board. So, or if we come to a place where we can't even make 4 in a row, it's like, you know, you have to have a tie. There may not be, we may have to wait and see at the end how many we actually do cover up. And maybe we can say whoever had the most covered up would possibly win at that point.
When I would play this against my classes, I won most of the time. Woohoo. No, there was a few times my classes had a tie with me.
All right, are we ready to pick that factor? All right, I am looking, if you know anything about me, I always like to kind of be strategic. So I either like to go.
Why do you always give away your things?
Because this is the way I think about it, and I want them to think about it too. So I try to think very strategically, where could I go that might give me an easy way to figure this out.
Give me away your strategy to me.
All right. Well, I'll try not to. How about I not do that? I'm going to go down here at this 54. That's just my thought. So I need to think about, well, what could be a factor of 54? I know 9 is a factor of 54. As well as 6 is a factor of 54. If I do 9 times 6, I could have 54. How about I just choose, I'm going to keep blue. All right.
So I'm only allowed to move 1 of these. So I am going to do 6 times 3, which is 18. Now, one thing Miss Sears did forget is we're allowed to block each other.
Yeah.
So if she's starting to get like 3 in a row and I'm able to get that, I can block her just like Connect 4. That's why I said the rules of Connect 4 kind of go with this one.
Yeah. And you've got my color. See, I would have taken it. I didn't have to tell her that. I'm going to change it now so I don't forget. All right, so she used the 6 and a 3. I have to reuse one of those factors. And I'm thinking that I'm going to go ahead and do the 6 and the 6. And remember, you can use it on the same factor. This is what we call a square number. We'd have a 6 by 6. So I'm going to do mine on 36.
So now I'm stuck with using 6 as one of mine. So in my head, I'm starting to think 6 times 1, 6 times 2, thinking about all the different factors and what would be near either mine or blocking her. All right, well, 6 is way over here. 12 is a little closer. We already have 18. 24 is way over here. They're,
Ooh, she better be careful.
oh, see, that's
See?
what.
I'm not telling her.
I wasn't thinking ahead, darn it.
All right. So I got a couple of different routes I can go. Her have choosing that 5 as a factor because I know that 5 is a factor in our 40, and I also know it's a factor in our 25. Here's kind of a little bit where I could be a little strategic because I know she could reuse the 5 on either of the places. I don't know. I am giving away too much of my strategy. I'm going to do the 5 times the 8. I kind of have an idea here. 5 times 8 is 40. So I'm marking that. Sorry, I'll need to remind myself to take that back. What do you think?
All right. I am going to do.
You might be. I mean, I have a thought, but I'm not quite sure.
6 times.
I thought I was predicting what she might be doing. But, this is kind of like interesting that you could figure it out differently.
I'm going to do 8 times 1.
Okay. Ooh. I think she was being sneaky while we were working on that. Because what are you noticing? She can be going diagonally here, right?
No.
All right, so she did have an 8, so that's good news. 8 is also a factor in 48, which she could go. So I just need to know, what else is the 8 times, that we could do that. I'm going to say it's 8 times 6. Let me make sure I turn my color so she doesn't think she got it and then start jumping up and down all for me, right? I'm going to do that. Still gives me some leeway. I may have a couple other spaces to do some 4 in a row work with, but I stopped her. All right.
All right. So
Now, if we had a 1 open, that might make it really easy to do there, right? But we don't have anything with a 1. Mm-hmm. But I can maybe see another route.
Oh, help me out.
So we have an 8 and a 6 covered. So she can only use the 8 and the 6. So I'm thinking 8 times 8 is 64. We already did 6 times 6.
Oh, listen to her. She's going to help me out here.
I'm trying to help her find a route that's in there. Not to say that I was already thinking about this beforehand, but it does kind of help. This is exciting, huh?
I'm going to do this.
Who do you think's going to get there? So you did 8 times 1, or 6 times 1, sorry. 6 times 1 is 6. Okay. Now let me think. Well, okay. So I've got to use a 1 or a 6. I'm going to use the 6 because I'm thinking I can go to that 42, and I know 6 times 7 is 42. I'm very, very close, guys. She's got to figure out a way to block me. Almost there. What do you think? Okay, let me change the color. She's got to use a 6 and a 7. Somehow in there. I think we only, this probably will be your,
I'm trying to remember.
this will probably be your last turn, and then we've got to wrap things up here in just a minute,
all
but
right.
go ahead. Take your time.
Fine then. All right.
And if you need paper and pencil, or if you even need things to manipulate at home, you could do that as well. You could be making these out into arrays, right? try to help you work on those facts, but you can certainly have something out there to help you working on it. Okay, so
7 times 3 is 21.
Okay. Now, if only I had a 15, right? I don't think I'm going to get to it yet, but
So
I could be very close to a few other places.
you guys notice we only have 1 to 9 to work on these factors. I was even thinking, if I had a 10, I could have put a 2 and a 10 together.
Yeah.
But I'm stuck with only these numbers to multiply together.
At the very close, the thing that I could probably do, I could have done a 7 times a 4 or a 7 times a 9, possibly, and tried to work getting in that angle, but it still would have stopped me. I'm still not going to get 4 in a row, at least in this time. But I do know that we have about only a minute or so left, so we just want to recap a few things that we had going on today. So in our first part of our lesson, Miss Gaudette worked with us on our different fractional pieces. We were doing kind of the idea of that unit fraction again. No? We
did the number of the day.
Oh, we did the number of the day. That's right. But then you did something with the fractional pieces on one of your problem-solving tasks.
Yes, on the problem solving
Yeah,
task.
we read a wonderful book called The Lion's Share, and we worked out basically the different halving of the cake, and then all the animals having to do the doubling of the cake. And then we played a really cool game called the product game. So
this is my favorite game in the world.
we just wanted to say thank you guys all for joining us today here with At Home at APS, and we'll see you again tomorrow. Have fun.
Bye, everyone. Have a great afternoon.